Okay, I'm going to work through the final exam review for Chapter 4 for Algebra 2. First off, we're writing a polynomial function. Simplest possible polynomial function I can with these zeros. So the thing you have to realize here is that the radical zeros come in conjugate pairs. So if root 3 is a 0, so would negative root 3, okay? And if you think about it, I is also a radical. It's the square root of negative 1. So this will also come in a conjugate pair. So that means if 2i is a root, negative 2i is a root. So both of these have a hidden 0 there, okay? And then what I'm going to do on these problems is think about, well, if those are the zeros, those are the things that x would equal if y is 0, okay? So if y is 0, well, I'm just going to write it as y now, but if this was one of my factors, then if I plugged in 0 for y, x would equal 2, right? So I'm kind of building this backwards, thinking about the zero product property. X plus 1 would give me a 0 of, give me an x value of negative 1, right? And then I have x minus root 3 and x plus root 3. Okay, so there's the first step, kind of just thinking about what this would look like if it was all factored and ready for zero product property. So now I just have to multiply this all together, okay? So what I'm going to do, I'm going to FOIL those two binomials. I'll multiply those two together. And I strongly recommend multiplying the conjugates together, okay? So yeah, you could multiply these two in the middle and you would get the right answer, but it gets really messy. It works a lot nicer if you multiply the conjugates together because the outer and inner will be opposites, and also the square roots will kind of take care of themselves. So I'm going to do two sets of FOIL here. So first, that's x squared. Outer is x, inner is negative 2x. So 1x and negative 2x will give me negative x. Last, negative 2 times 1 is negative 2. Okay, and then first outer, inner, last again. First here would be x squared. Outer would be positive x root 3. Inner would be negative x root 3. And then last, this is the part where I feel like the most mistakes get made. I've got negative root 3 times positive root 3. Well, a negative times a positive is going to be negative. Okay? And then root 3 times root 3 would be root 9, which is actually just 3, right? So when you look at that, this second parentheses, those are opposites. That always happens when you multiply conjugates. So you don't have to do the O and the I from FOIL because they'll cancel each other out. You just need the first and the last. And then this second part's going to be negative 3. So that second parentheses simplifies to just x squared minus 3. Okay, I still want to multiply these together. I can't FOIL because I've got a trinomial. So what I'm going to do is set up a multiplication table. I'm going to take the 3 terms from the trinomial there and the 2 terms from the binomial here. And I'm set up a multiplication chart. Okay, x squared times x squared is x to the 4th, x squared times negative x to the 3rd, and so forth. Okay, so I've got those pieces. So now I'm just going to combine my like terms here. So x to the 4th, there's only one 4th degree term, but whoops. And there's only one 3rd degree term. But then there's 2 x squared terms, so I want to combine those. So that's the only one that I can combine actually, right? The x squared term. So let's see. X to the 4th, this would be negative x to the 3rd, and this is going to be negative 5x squared plus 3x plus 6. Okay, and there we go. Whoops, I'm off screen a little bit. Okay, I just added up all the terms from those boxes. All right, so here, I'll put the answer in right up here. Definitely not enough room to do all that work on the worksheet. Okay, here's number 2. Same kind of deal. It's just I'm dealing with some imaginary numbers, so I'll set this up first. Like so. Okay, and then I'll start foiling. I'm going to FOIL those two, and I'll FOIL those two. So again, multiply the conjugates together, makes life way easier. So first here, x squared outer's 2x, inner's negative 3x, so that combines for negative x. Negative 3 times 2 would be negative 6, okay? And then over here, x squared, outer and inner are opposite, so I'd have 2ix and negative 2ix. And then the last is going to be negative 4i squared. Okay, so outer and inner are gone. Okay, and then another thing you want to watch out for, I squared equals negative 1 because it's the square of the square root of negative 1, so it's negative 1. Okay, so this last term would be negative 4 times negative 1. Well, that's positive 4. So the second parentheses is going to simplify to x squared plus 4. And then I'm going to do one more round of multiplying like I did over here using a multiplication chart. Can't FOIL because I've got a trinomial in the mix there. Okay, and then I'm going to combine those like terms, and heads up, we've got like terms again in those two positions. So negative 6x squared and 4x squared would be negative 2x squared, x minus 24, and there we go. Okay. All right, moving on. All right, find the product or quotient. All right, this one we're dividing. You could do long division. I'm going to do synthetic division. So anytime you have x plus or minus something, when you're dividing by that, it's fair game for synthetic division. So here I think, well, if x minus 3 equaled 0, then x would equal 3. 3 is what I'm going to put in this little box. This is for number 3. 3 goes there, and then I'm going to use the coefficients here. I'm checking there's no missing terms. So there's an x to the third, x squared, x, and then just a constant. Okay, so there's no missing terms, but I'm looking for that because if there was a missing term, you need a 0 as a placeholder. Okay, so I just take those coefficients, I write this little bar. Okay, I'm going to pull down the 3, and then anytime I get a number down here, I'm going to multiply it by 3. So 3 times 3 is 9. The 9 goes here. I add these together, 15. 15 times 3 would be 45. Add these for 40. 3 times 40 is 120. Add those together, so that's going to be 132. Okay? So this last number down here is going to be the numerator of the remainder. Okay? The denominator is whatever you're dividing by, in this case, x minus 3. Okay? I'm going to build my answer then from right to left. So as you go left, this is going to be just a constant. So this is just the number 40. But then this is going to be a 15x and a 3x squared. So as you go left, you add 1 degree of x as you go. So you always start with a remainder and then a constant, and then you add 1 degree of x as you go left. Or another way to think about it, if you want to build it from left to right, if you divided those, you'd end up with 3x squared. You know, 3x to the third divided by x would be 3x squared, so you know it's going to begin with an x squared term. And then you can work your way down from there, okay? And there's our solution. Okay. X squared is 15x plus 4, 2x minus 3. All right. Next up, we've got a binomial that we're expanding. So one way to do this is just to multiply it out. You could FOIL, and then when you FOIL those two, multiply that by 3x minus 2. Nothing wrong with that. I'm going to use Pascal's triangle because we can use that to expand a binomial. So here's what Pascal's triangle looks like. Okay. So this would, you might think that would be row 1 at up top, but it's actually row 0. This would be row 1. This is row 2, and here's row 3. Okay? So I'm going to use row 3 from Pascal's triangle just because this is a third degree equation. I'm going to set up a little chart. and I'm going to put the numbers from the triangle from row 3. I'm only using row 3 here, up top. Okay. And then for a, that's going to be the a term from my binomial, which would be 3x. So I'm putting 3x in parentheses all the way across here. Okay, and my b term is going to be the b from the binomial, which is -2. And I'm going to put that in parentheses as well, all the way across here. Okay. Now I need some exponents. So since this is third degree equation, I'm going to start here with a 3 and work my way down to 0. If you don't end up on 0, then you use the wrong row from Pascal's triangle. And for the b's, I'm going to go the opposite direction. So I'm starting with 0 and working my way up to 3. Okay. Now the first term of this, if I did all this multiplication, the first term is going to come from this. Okay. I'm going to multiply those pieces together. 3x to the third, well, 3 to the third is 27, and then x to the third is x to the third. Anything to the 0th power equals 1. Okay, so my first term then is going to be all of that multiplied together, 27x to the third. My second term is going to come from this. So I'm going to kind of simplify this as I go. 3x times 3x would be 9x squared. I do the product of those three pieces, okay? And then -2. Okay, so I've got 27 times -2 is going to be -54 x squared. I always space these poorly, but let's see if I can get this in here. -2 times itself is +4, so let's see, 9x times 4 would be 36x. That comes from this piece. Okay, and then last up, I'm going to have 1 times -8. Okay, which is -8. And there we go. Should get the same result if you just multiply it out by hand. Okay, I'm going to stop there because I got a class coming in, so I'll continue this later. Okay, let's get back to this then. All right, next problem, number 5. I'm going to multiply everything together. So, let's see if I can fit this down here. Okay, so first I'm going to FOIL to multiply those two together. So first, outer is 3m, inner is -2m. So 3m and -2m would be 1m. And last, -2 times 3 is -6. Oops, -6. And okay, got it down to this. Now I can't use FOIL again because I got a trinomial, so I'm going to set up a multiplication chart. So I'm going to put the trinomial terms here going down on the left. And there's my binomial terms. And it's just a nice way to keep track of all the multiplying we're doing. So you don't, I mean, some people like to distribute the m and then distribute the -1. That'll work. This is the same thing, really. We're just can't really lose your place with this chart. So I like this method. Okay, m times m is m squared, m times -6. And then I'm taking the opposite of these three terms when I'm multiplying by -1. Okay, and then I'm just going to add up the pieces for my final answer. So let's see. I'm going to kind of look for like terms here. They're on these diagonals. And actually the m squared and the -m squared are going to cancel each other out. So then what I have left is m to the third. This is going to be -7m plus 6. Okay, put that in chart up here. I'll put that on the page, I mean. Okay, all right, that's the end of that little section. So let's, oh no, it's not, there's more. Okay, so now I've got 5x plus 3 to the second. Now you could use Pascal's triangle for this with row 2. It would have 3 terms starting, I'd use these coefficients if I set this up with a chart, but I'm just squaring this. So big thing I want to point out on number 7, the big mistake that gets made is that people will just square both of the terms. So this is going to be incorrect if you just say, oh, this is 25x squared plus 9. That's incorrect. Don't do that. Because this is binomial times itself. You want to FOIL. So I would do this by FOILing. I wouldn't bother with Pascal's triangle. It's not really worth it when I'm just got a second power. So first is 25x squared. Inner is going to be 15x. Sorry, outer is 15x. Inner is also 15x. So 15x plus 15x would be 30x. And last, 3 times 3 is 9. So you see, if you just square both the terms, you'll miss out on the 30x. That is part of the answer. Okay. And then number 8, we've got another multiplication chart. Here, I'm going to start a new piece of scratch paper here. Okay, so here's number 8. So I'm going to set up a multiplication chart. There's my binomial. Here's my trinomial. And it doesn't matter which one goes on the top of which polynomial goes on the top of the chart and which one goes on the left. So you could switch those. Okay, but let's start multiplying. So z to the 2nd times z to the 5th would be z to the 7th. I like to use the little lines through my z's so they don't look like 2's. Okay, there's all the pieces. Now I just add them up. I'm going to look for like terms. I don't have any like terms. These are all unlike terms. So I'm just going to put them in descending order. And there we go. Okay, let's see. All right, next up. The volume in cubic feet of a shipping box is modeled by this polynomial function where x is the length of the box. Okay. Explain how you know x equals -2 is not a possible rational zero. Okay. So, okay, there's no number 9. How about that? So we're going straight to number 10. All right. So the rational root theorem says that I should have the factors of 20 over the factors of 1. So the factors of my constant over the factors of the leading coefficient. Okay, so my possible rational roots, I'm making a big fraction here. I'm thinking, what are my factors of 20? Well, 1 goes into 20, so does 2, but so does -1. So I want plus or minus 1, plus or minus 2. 4 goes into 20, 5 goes into 20, 10 does, and then 20 itself goes into 20. I think I had all of them there. Okay, and the only factors of 1 are positive or -1. So it's really these integers, 1, 2, 4, 5, 10, or 20, positive or negative. When you multiply or divide by 1 or -1, it's still going to be those integers. Okay, so -2, how do I know it's not a possible? Well, it is a possible rational zero, but I guess they're asking how do I know it's not actually a rational zero. Well, I'm going to test it out. So I'm going to, I thought they were getting at this and that it was not going to be on this list, but it is on the list. It's a possible rational zero, but I'm guessing it's not an actual one. So I'm going to test this out by synthetic division. I'm going to see if this goes in evenly. So I'm going to see, when I do this, I'm seeing if x plus 2 would be a factor of this polynomial. So that's why I'm putting -2 in this box itself, okay? So I'm going to use these coefficients then. 1 is my leading coefficient, then -2, then -19, and it's not missing any terms. So if I get a 0 remainder, this is a 0. If I get anything else, it's not going to be a 0. So let's see, I pull down the 1, I multiply by -2 there, I add these, then I multiply by -2 again, add these, and then multiply, and hey, I didn't get a 0 remainder, so that's my explanation. So no 0 remainder, therefore x equals -2 is not a 0. I don't like how that's worded because it is a possible rational 0 based on the rational root theorem. But okay, so that was part A. And then part B, show that x plus 4 is a factor. All right. So if x plus 4 is a factor, I'm thinking if x plus 4 equaled 0, then x would equal -4, right? So I'm going to use the same, I'm dividing into that same polynomial, and I'm expecting to get a 0 remainder, and that way I can show that this is going to be a factor. Okay, pull down the 1, multiply, add, multiply, add, multiply, and sure enough, I got a 0 remainder. So there, I've showed that it's a factor. It says then factor completely. Okay, so I got to go a little farther. If I take that original polynomial, I've factored out x plus 4. Okay, and what I have left over is this trinomial. So this would be a 5 and -6x and x squared. And we're asked to factor this completely. Okay, so I just want to factor the trinomial part. Okay, and it's always possible you'll get a trinomial that's not factorable, but I'm thinking this one is going to be factorable. I'll set up a diamond problem. Okay, and then -1, -5 is my winning combo there. And now this is completely factored. And I could find the zeros. The zeros would be -4, 1, and 5, which are all on that list. They're all rational zeros. Okay? All right, that is it for this page. Okay, let's have a look at the second page then. Okay, you have decided to start a dog walking business. We've got a table below, we've got profits in dollars, and it's the first 6 years of the business. So, okay, years 1 through 6, there's our profits. Ouch, $7 in year 1? Ouch. Okay, use a graphing calculator and finite differences to find a polynomial model for the problem. Then use the model to predict your profit after 10 years. So I want to figure out what type of an equation is going to fit this data. So I'm going to look at the first differences. If the first differences are constant, if I get the same thing for all the first differences, then this would be linear. It'd be a first degree equation. Let's see, going from 7 to 11, I'm going to add 4. And then I'm adding 12 here, and it's early in the morning. And that's going to be 26, and 95 minus 49, let's see, that is 46, and then 167 minus 95 is going to be 72. All right, so my first differences are not the same. So then I'm going to look at the second differences, and this is kind of in the way. I'm just going to do this down here. If these second differences are the same, then this would be then this is going to be a quadratic function that fits this. So 4 to 12, I'm looking at the difference between 4 and 12. I'd have to add 8, and then 12 to 26, I'm going to add 14. 26 to 46, I'm adding 20. 46 to 72. I am adding 26. Okay, so hey, it's not second degree either. So let's look at those differences here. Let me zoom in a little bit. This is getting pretty small. This isn't spaced out great. I'm ruining the next problem. All right, so let's look at the third differences. Maybe it's cubic. 8 to 14, I would add 6. 14 to 20, I'm adding 6. And 20 to 20, hey, look at that. So my third differences are constant. That means this is going to be third degree. It means it's going to be cubic. Okay, so I'm going to write a cubic function to fit this data. I'm going to use my calculator to do this. You can do it with a system of equations, but it's kind of a pain. So I'm going to do this with a graphing calculator. Okay, so I'm going to first input this XY table into my calculator in the statistics menu. So statistics on these TIs, it's been a while. There it is, stat. The stat button right below the delete button there in the middle near the top. Okay, I'm going to hit that, and I'm going to hit edit, and I've already got some stuff in there. So, you know, you can do an XYZ table or whatever. I just want an XY table. So I want to clear out this stuff in the first list 1. So I'm going to just highlight L1, hit clear, and enter. You can delete the entries one by one, but I like to do that. So if you got stuff in there, delete it out. Make sure you don't have anything, anything in the other columns either, because that will throw things off. All right, so my x's, 1, 2, 3, 4, 5, 6. I'm just going to hit 1, enter, 2, enter, 3, enter, 4, enter, until I get to 6. And then my y's are going to be 7. So every time I plug one in, I hit enter to actually enter it into the table. Okay, got that in there. All right, once you get the XY table in there, you're going to go back to stat. It'll keep this data in there. So the stat menu again. Now I'm going to do a calculation. I edited before, but now I'm going to scroll over to calc, and I'm going to do since I know this is a cubic function, I want to do a cubic regression. That means it's going to take those xy pairs and try to fit them into an equation. It's going to find the best equation it can that goes through all those. Okay, so I hit enter to choose cubic regression, and then I hit enter once more to actually run the program. And then this comes out. All right, so I've got an equation in this format, and they're telling me what A, B, C, and D are. So I'm going to have 1x to the third minus 2x squared plus 3x plus 5. Okay, here, let me put that right here. Okay, all right, so there is my equation. Now I could, you know, go 100 years down the road if I wanted to. I just plug in 100 for x. Here I'm only looking for year 10. So let's see what kind of profit we'd have in year 10. It's impressive, this business. They kept it going after they only made $7 in year 1 and $11 in year 2. Okay, so 10 to the third, it's 1,000. I'm going to have negative 2 times 100. Okay, and that's going to give me 835. So should be making $835 in year 10. Now we're talking. All right. Okay, next up, I kind of made a mess of this one. This says the graph of a cubic function is shown. Okay, describe the degree and the leading coefficient. Well, they give it away. Describe the degree. It just said it's a cubic function. So the degree is its third degree. That's not really what they're getting at. I think they're looking at the end behavior here. But, okay, so if the leading, so if you think of the simplest possible equation that has the same end behavior, it would be a straight line. It would be actually the line y equals x. Okay, and when you're looking at that, anything that has this positive leading coefficient and an odd degree is going to have the same end behavior. So if I had something like this, that would have the same end behavior. Or if I had this, that would have the same end behavior. So if it was the 91st, it's still going to have that same end behavior where it starts low and finishes up high on that side. Okay, so that's what they're getting at here with the end behavior. I mean, describe the degree. If I wanted to really describe it, it's third degree. That's a great description. But I think they're talking about we're going to have an odd degree and a positive leading coefficient. Okay, all right. And then we've got a lot of factoring to do. Okay, so this first one, in factoring, I'm always looking for a common factor. Here, all three terms have an x, so I can factor that out. Okay, and then I'm thinking, oh, I've got a trinomial. Maybe I can factor that. I'll try to factor that with a diamond problem. Or maybe you can just do it in your head. You don't necessarily need to use a diamond problem, but got -1 and -12. Okay, so 3 and -4 is my winning combo. And this is factored. Okay? All right, next up. So, hey, 9 goes into both of these terms. Also, p to the 5th goes in, so I can factor out 9p to the 5th. So this would just leave me with p squared in that first slot. In the second slot, I'd have -4, just -4. Okay, so I got it down to this. Now I'm looking at the binomial here, and I'm thinking, wait a second, that's a difference of squares, right? P times p is p squared. 2 times 2 is 4. It's a difference because it has the minus sign in the middle. So the pattern that's going to follow when I factor this binomial, it's going to be p plus 2 times p minus 2. Okay, and then there's no more factoring to do. That is completely factored. All right, next up, going to need a formula for this one. This isn't a difference of squares. There's no common factor. Oops, that's off screen. There's no common factor. It's not a difference of squares, but it is a sum of cubes, because x times x times x is x to the third, and then 3 to the third, 3 times 3 times 3 is 27. Okay, so you need a formula. Here it is. Okay, so I'm going to follow this format. It's just instead of a and b, my a and b are going to be x and 3. Okay, so this is going to factor to x plus 3. And then I like to do blank parentheses when I'm filling this out, just to make sure that I simplify it correctly. So first 2 slots, these 2 slots are a's. That's going to be x for this problem. And the second 2 slots are b's. That's going to be the 3's. Okay, now I'm going to simplify. I just forgot to end my parentheses there. Now I'm going to simplify this trinomial. I can't do anything with the x plus 3, but it's still out there in the front. Okay, so then I've got x squared minus 3x plus 9. Okay, and it's tempting to try to factor the trinomial here, but it's not going to be factorable. If you use one of these sum of cubes or difference of cubes formulas, you're not going to be able to factor the remaining trinomial, unless you didn't factor out a common factor at the beginning. But if you've done that, then you don't have to worry about the trinomial. It'll be a dead end. Okay. Next up, I've got 4 terms here. I can see there's no common term with all 4 terms, but maybe if I group them, when I have 4 terms and there's no common factor, make a group out of the first 2 terms and the last 2 terms, and see if you can factor it then. So out of that first group, hey, I can factor out y squared. So that would leave me with y minus 3. Okay, out of the second group, I can factor out a 4. And I've got this. Okay, so this is factoring by grouping, and you know you're on the right track if you get these matching pieces. You know this is going to work by grouping. Okay, so now I'm going to factor y minus 3 out of, you know, this whole front piece and this whole back piece. So I'm going to factor a y minus 3 out of both of those. Okay, and then, you know, I factored a y minus 3 out of here, so I'd still have a y squared left. And I factored a y minus 3 out of this, so I'd still have positive 4 left. Okay. Another way you can think about this, sometimes people get confused on that. Hey, I had 2 of them, then I had 1. Well, I factored it out. But you can just make a parentheses for the parts they have in common and a parentheses for the leftovers. Okay. And then I'd still want to check to see if there's any more factoring I can do. It's kind of tempting here because I've got some perfect squares, but that only works if it's a difference of squares. I can't do a sum of squares. If there's no common factor, you can't factor that. You can factor a sum of cubes, right? And a difference of squares like we did somewhere. Oh, up here. This one was a difference of squares. But you can't do a sum of squares. All right, next up. This is a quartic trinomial. Means it's 4th degree, then 2nd degree, then a constant. And you can factor this with a diamond problem. So I'm going to put 11 up here and a 28 up here. Okay, I'm looking for two numbers that add to 11 and multiply to 28. How about 4 and 7? Okay, but it's not just going to be n plus 4 times n plus 7, because if I did that, if I just said n plus 4 times n plus 7, if I FOILed it together, my first term would be n squared, not n to the 4th. Okay, so the only difference here is that you need n squared in the front of both of your parentheses to give you the n to the 4th. And then you just put in the 4 and the 7 at the back of each, just like you would if it were a typical trinomial, a quadratic trinomial. Then I'm checking these. No difference of squares, no difference of cubes or anything like that, no common factors. So this is completely factored. Okay, so I'm going to use that same technique on this next problem. I'm going to first factor this, and then I should be able to solve it from there. Okay, I think I'm going to need some scratch paper for this one. All right, so let's try this out. So I'm going to plug in 0 for y so I can find these x's. I can find the zeros. That's what the zeros are, right? The x values that make y 0. They're the x-intercepts is another way to think of it. All right, and then let's see. I'll maybe put my little diamond problem here. Okay, so 4 and 9 will work if the 4 is positive and the 9 is negative. So this is going to factor to x squared plus 4 and x squared minus 9. Okay, now checking that out, I've still got, let me zoom out a little. Okay, I've still got a difference of squares right here. Can't do anything with x squared plus 4, but I can factor the second binomial there. That's going to be x plus 3 times x minus 3. Okay, so I've done all the factoring, so now I'm going to start using the zero product property to solve for x. So either this equals 0, or one of these equals 0. Okay, so I got those two. All right, x squared plus 4 equals 0. Well, I can't factor it, but you can still just solve for x. So I'll subtract 4 from both sides. Then I'll take the square root of both sides. When you take the square root of both sides of an equation, I feel like I could repeat this for the rest of my life and and still see a lot of people forget to do that. I understand, but yeah, plus or minus, you need that, okay? Then, since this is, you could think of this as negative 1 times 4 in here. Well, the square root of negative 1 would be I. So anytime you got a negative in your radicand, you can just pull an I out there, and now it's I root 4. Wait a second, root 4 is 2. So this would be I times 2, or 2I. Okay, I've got these 4 solutions, and that makes sense if you look at the original problem. The fundamental theorem of algebra tells me that if this is 4th degree, it should have 4 zeros. Now it's only going to have 2 x-intercepts, but it still has these 2 other zeros, but these are imaginary. Okay, so yeah, let's see. I got plus or minus 3. And I've got plus or minus 2i. There's the 4 different zeros. Okay, and last but not least, number 20. So this one, I usually try to factor these if I can. Looking at this, I've got 5 terms. There's no common factor for all 5 terms, so I'm not going to be able to factor this. Okay, so next thing I'm going to do then on 20 is I'm going to think about the factors of 6 over the factors of 1. These are going to be my possible rational roots. So I'm thinking, and you don't necessarily need to write these down, but kind of just be thinking, what goes into 6? These things go into 6, and only 1 and negative 1 go into 1. So I'm looking for 1, 2, 3, or 6, positive or negative. So, you know, there's 8 different options here. You could try them one by one. I'm going to use synthetic division to test these. But just to make things go a little bit quicker, I'm going to use a graphing calculator and look for x-intercepts at one of these places so that I don't have to try all of these out. We'd be looking for a 0 denominator, and then we'd know we'd have zeros, okay? But I'm going to go to my calculator. I hit the y equals button to get to the graphing place. I'm just going to hit clear what was already there. So x to the 4th plus x to the 3rd. Minus 7x squared minus x plus 6 Got it all in there. Now I'm going to hit the graph button. Okay, and I'm going to look for 1, 2, 3, or 6. Oh, I've got quite a few x-intercepts there. It looks like -3, -1, +1, and +2. So I'm thinking, and these are guesses. I don't know, because these could be close to that and not exactly, but it looks like -3, -1, +1, +2. I'm thinking those are my my zeros. So let's go ahead and check if they really are. I'm just going to try them one by one. If -3 is a 0, I should get a 0 remainder here. So I'm using the coefficients. There's no missing terms in this polynomial. If there was, I'd have a 0 as a placeholder. Okay, pull down the 1, multiply by -3, add, multiply, add, multiply, add, multiply. Hey, I got a winner. Okay, so that one works. All right, so now I'm going to try the next one. I'm going to try -1. Instead of going back to the original polynomial, I'm going to divide out of this thing, because then I'll keep whittling this down. Because if it goes into this, it should also go into the original polynomial. And it saves you time, but also then you can whittle down the polynomial. So at a certain point, you'd be able to factor it by hand. Okay, so I'm pulling down the 1, multiplying, adding, multiplying, adding, multiplying, adding 0. Okay, so I've got another winner. All right, now if you pulled this out, we factored out x plus 3 and x plus 1. And this would be x squared minus 3x plus 2. So I could actually just factor this trinomial by hand. But I'm already on a roll with the synthetic division, so I'm just going to keep going with this. Ooh, running out of space here. Pulling down the 1, multiplying, adding. Here, let me separate this. Multiplying. Hey, I got another winner. Okay, all I have left here is 1 and -2. So I'm going to move over here and do one more round. I'm going to try +2. Very little to do here. Just pull down the 1, multiply, add, and that one worked as well. Okay? And then there's nothing left here except the number 1. So if you think about how this would look factored, this one isn't asking you to factor, but I factored out x plus 3, factored out x plus 1, factored out x minus 1, and I factored out x minus 2. Okay, and then all that's left is a 1, which doesn't really do anything, right, because it's just a 1. So our zeros then are going to be all these, right? They're the guesses. And you could get that from zero product property here. Okay, and that is the end of the review assignment, and I'll see you next time.